Alright, so last page here. Class example number 4. We're starting with the graph of 6 over x squared plus 3. So if you need a little bit of help drawing that, I'm just going to ask that you get your calculators out. And in your y equals, you'll put 6 divided by, and it's important to put the entire denominator in brackets. So x squared plus 3 is your denominator. When you graph it, you're going to get a function that looks like this. And if you want, you can change your window settings to get a better picture. So I'm just going to go -5 to +5 on both the x and the y axis. Hi, Mr. Paul.
Hey.
Okay, so we haven't seen too many of these functions, but just talking about domain and range a little bit before we get into the reflections. If you take a look, we have a maximum to this function, and that looks like it's at the point 0, 2. Okay, it's not going above that. Then if I follow to the right, it's approaching the x-axis, but it's not touching the x-axis. Okay, similar if we go to the left, it's approaching y equals 0, or the x-axis, but it's not touching it. So we're going to learn this in a later unit, but we have what's called a horizontal asymptote, and it's not going to go past that line, or it's not going to touch that line. Okay, it's approaching the x-axis. So what we're going to do is we're going to look at this original function now, and we're going to reflect using the following notations. So as you can guess, it's probably going to be a reflection in the y-axis, the x-axis, and the mirror line y equals x. Okay, so why don't we start by writing the equation if we had y equals -f of x. Okay, again, what is happening? Reflection over the x-axis, good. Okay, so that's reflecting over the x-axis. So if that's happening, then we need to take the original function, which is 6 divided by x squared plus 3, and there's a negative in front, so we're just multiplying this by a negative. So our new function, or equation, will be y equals negative, and then 6 over x squared plus 3. If you wanted, you could take that negative and apply it to just the -6, or you could leave it out front like we had it. But it only goes to either the numerator or denominator, not both. So looking at our original function, we're reflecting in the x-axis. So if we were to draw that, we would take our maximum, 0, 2, and it would become 0, -2. Okay, again, it's going to approach that x-axis, but it's not going to touch it. If you're unsure, put that in your calculator, and you can test it. You guys ready for part 2? Okay, what's happening here? Reflection over what? Good, reflection over the y-axis, and that's obvious because the x values are changing. Okay, so if the x values are changing to negative, that means I'm going to take my original function, and instead of an x, we plug in a -x. So we get y equals 6 over -x all squared plus 3. When you square a negative, what happens? Becomes a positive. Okay, so it's important you put the brackets here, so you just remember if you go negative times negative, it's positive. So just to make things nice, okay, this would be our original, or our new graph, 6 over x squared plus 3. Is it any different than what we started with? No. I will just keep that there so you have it in your notes and you knew to put in the negative. But you end up with the exact same thing. And that makes sense because if I were to take this side and look at it in comparison to the other side, does it look completely symmetrical? I'd say so. So if it switches sides, it's going to look exactly the same. I'll just put that we reflected over the x-axis here. Here we're reflecting over the y-axis. So it's going to look exactly the same. We still have a maximum at 0, 2. It's going to approach the x-axis. Lastly, we need to find the inverse. Okay, so that's going to be a reflection over the line y equals x. And in that case, we switch the x and the y. So we get x equals 6 over y squared plus 3. And then we need to solve for y. So I'll just put that work over here. Let's see a bit better. Okay, so if we started with x equals 6 over y squared plus 3, then we basically want to take this denominator and this numerator and switch them. Okay, to show you longhand, we want to get the y out of the denominator. So I have to multiply by y squared plus 3. It's going to cancel out on this side, but whatever you do to one side, you have to multiply to the other. So now I have y squared plus 3 all times x is equal to just 6. We got to get rid of that x, so divide by x. Whatever you do to one side, do to the other. So 6 divided by x on the right hand side. Then we're left with y squared plus 3 equals 6 over x. We need to move the 3 over, so we'll subtract it. We get y squared equals 6 over x minus 3. And then lastly, we need to take the square root. So y will equal the positive and negative square root of 6 over x minus 3. So there's one of two ways that you can figure out what this new graph will look like. You can put in your y1, the positive square root of 6 over x plus 3, and your y2, the negative square root of 6 over x minus 3. Or we can just review how to draw our inverse on our calculator. So let's just do that for practice. Second program. Oops, let's go down to here first. My calculator's frozen. Let me load it up again. Okay, so we started with 6 divided by x squared plus 3. And that's what it looked like. And then if I figure out, you'll go second program, down to number 8. You get draw inverse, press enter. And then you need to tell your calculator what you're taking the inverse of. So you're going to go vars over to y vars. Still with us, Emily? You still with us? Okay. Number 1 for function, y1, and then enter again. So as you can see, it's moved from here to here. Okay, if we noted that our maximum point was at 0, 2, and then we take the inverse, what does this point change to? It goes to 2, 0. Okay, so we'll go over 2, 0. And then we can just draw our graph through there. Okay, we didn't actually have to put it in our calculator to draw it. Maybe I'll do a nicer one. But this would be reflection in y equals x. How are we doing so far? It's so easy that you guys are just bored. Is that it? Okay, we have one more question, and this is a combination of transformations or reflections. And this is the bit that we skipped over in the last lesson. So we'll see how you guys do with the notation. We talked about it a bit, but we didn't do all the drawings. So if we have an original function f of x, which is 3x plus 2, and we're asked to take x equals f of y, what am I taking? Inverse, good. So let's do that. Okay, so we started with y equals 3x plus 2. If we take the inverse, we get x equals 3y plus 2. Then we solve for y. So if we do that, we gotta subtract the 2 over, and then divide by 3. So that's our inverse. Okay, but let's look at the next one. X equals f of negative y. So there's a combination of two transformations here, two reflections. First we have the reflection in the line y equals x. We know that because the x and y are switched. Okay, but if y is now negative y, so y is replaced with negative y, what are we reflecting over? Good, the x-axis. Okay, so what we have to do is if we've already found, if we're looking for the equation of this, if we've already found the inverse, there's no sense doing it again. Okay, we already have it, so instead of y, what do we have? Negative y. Okay, this is now a negative y, so this y becomes a negative y. So x minus 2 over 3 equals negative y. But as I've mentioned, we typically just have a y equals equation. So if I divide by negative to the other side, you could have it as negative x plus 2 over 3, or you could have written it as x minus 2 divided by negative 3, or you could have just put the negative out front. Okay, just to keep your life a little bit easier, maybe I'll just put that negative out front and leave that as x minus 2. Just note though, if you distribute that negative, it can only go in the numerator or just the denominator. It doesn't go into both. Did that answer your question? Or did you have a question?
No.
Oh, sorry. Okay, going to part 3 here. Okay, again the x and the y are switched, so we have an inverse that goes to part 1. Okay, but this time we have x equals negative f of y. So if I were to rewrite this, it would write as negative x equals f of y. So we see that the x is replaced with a negative x. If x changes signs, we're reflecting over the y-axis. Okay. Going back to the original inverse equation here, we have x minus 2 over 3 equals y. But we agreed that negative, or x is replaced with negative x, so we're going to sub that back into here. So negative x minus 2 over 3 equals y. And we can leave it like that. If you want, you can get rid of the brackets too.